This is today my first day in a new company, Pattern Innovations. Alex here, CTO. You want to join us, come talk with him. But as I said, the product I'm going to talk about is from completely different companies. So company I worked for the last 5 years, it's called Flabit. You might heard about them and you might not. So they used to do sales on demand, which you would provide them URL from Amazon and they would try to find you a better price. There were stuff happening in the background that I will mention that I took part of. They transformed now the model to be full-fledged marketplace and they are trying to compete with Amazon. So what we really are going to talk about history of the project, because this project is like 6 years old, about how we separated the concerns for the service that was already there, introduced the microservices, split everything to those three scrapers, Spider and Downloader. What we see as potential pain points, what we acknowledge as a problems afterwards, and the architecture and the Q&A. So long time ago, it all started as a PHP crawling of Amazon, mostly. You can imagine how bad it was and how few requests they could do at the same time. But it worked and everybody was happy, and then they started having more clients, and then they arrived there. So going through Scrapy, through other products, they created a scraper in Python and twisted. It wasn't bad, it worked, but as it worked, business started having different requirements for the scraper, which means like 2 different departments wanting different data, and they have to branch, and they end up having 4 branches that were unmaintainable if they wanted to do fast changes, if the HTML changes or anything. And the speed, well, it was fine in the beginning, but as some of the pages they scraped started to filter stuff out, it turned out it was really hard to even debug and see what's happening on the network layer and to try to tackle problems. We spent with friends, with one of the colleagues that used to work with us, 2 or 3 weeks trying to even understand how the headers were mixed up between different requests. So around 2 years ago, 2.5, I became head of internal services in Flabit, and I inherited 2 projects, PyScraper and the stuff they called TMS, which was supposed to basically manage the pool of proxies. So as we were already having problems with Scraper and the business has growing requirements, so at that time they were doing 50,000 requests per day, but they wanted, of course, to do more, and the PyScraper wasn't getting them there. So we look at this and we knew that we have the most problem with the network layer. And we know we will have a long battle ahead of us. So we started by splitting the network layer out. And this was the first time that we introduced in the whole part of this project Node. So we create a service called Downloader that were still talking with the old service, giving us proxies, but managing the connections, managing reach writes, managing headers, spoofing browser, rotating user agents, doing all this kind of neat stuff, we got to the point where we are actually sending UR agents over actual browsers, trying to mimic behaviors of browsers depending on the user agents. We were deflating content and stuff like this. So this became very neat, and we started introducing at this point Jenkins pipeline. This is stuff that I used on different projects previously, so I started introducing this here as well as a build tool. So we did Downloader, everything was fine, we understand what's happening on the network layer, right? But there was still this other part that was in Python, and it wasn't getting any better in terms of performance, because we could do now around 500,000 requests per day, but we couldn't scale this up unless you would just buy larger boxes. So we took a look at it and cut it in half, separated concerns. The content analytics went to Spider, and the caching and crawling, future product intelligence, other sources of enhancement went to another layer in Node. And with that, we completely managed to get rid of Python. It was like the most successful thing I managed to this company, to get rid of that. So what we've actually arrived at in the end, there are going to be 3 graphs like this. This is the most complicated part of this talk. So you would see, first we would read from the business, from RMQ input, the job, then we will understand if we have this in cache or not. Then we will forward this to Spider, saying, hey, please give us content for this. Spider would just forward it to downloader. Downloader will assign proxy, do the job, give stuff back, just cascading up to the client. The database updates queue, for performance reason, was completely separated as a different sub-process of scraper, and that's it, right? So, the scraper part. We use Typescript. As I said, we use RMQ as method of accessing the queues. A single scraper could use from multiple queues or could use one queue. You would set up what's the prefetch that you want to do. The same code base would be shared with the update process. That would be a separate thing, but sharing all the models and all the other stuff with the main code base. We use Mongoose to manage this. As I said, by this we created a layer that gave us ability to, in future, do different kinds of integrations, do different kinds of scraping, and I will get into this a bit later on. This is not part of the main presentation, but part of the stuff that we did there, and it's interesting. We expose GC. I know it's not the casual thing to do, but we found out that when we saved massive logs with Logly connector to Winston, we kind of have to do this to kind of keep our memory on some decent levels. Otherwise, we'll just go out of the way, just Logly stuff. So callback or promise. Well, we kind of structured this so that the callbacks kind of would outline the flow of application, which means you could easily browse and find what you're doing at. And we use promise when we would interact with models of stuff that we won't kind of, usually models, but kind of we might want to interface, or we don't actually need this to understand the logic of the application. And we try to keep the balance between both of them. And the same goes with functional and object-oriented. We try to actually have modules that would be derived, that would be object-oriented, but the way we would handle the data was completely functional. So we would focus more on having reliable methods that we can test easily, just putting data in. And said this, as I said, the scraper does only two things. So checks if something is in cache, does the proper procedure, and sends stuff out to Golang. I won't be talking much about it. We choose this because, well, power of parallel processing, really. We imagine you have a single string, large content that we needed to do CSS, XPath selectors, and then regex on it. It's not good for Node at this point. So we actually gave it to Go, and it's very, the Go itself, if you're doing Typescript, the Go, you will find it very you will find you're at home with some small stuff. Closure and async works the same in Node. You're doing async in Node properly, you will just kick off your Go stuff, but that's not part of this presentation. And then you arrive to the third service that this is the oldest one that we started separating first. So it actually consists of 3 internal loops. Now, this service should be separated to two different, and this is why those 3 separate loops are there. But they are designed this way that they do not create blockage for each others. So as a job comes in, we'll move back to it for a second. As a job comes in, it goes to job manager that kind of prepares that acts the log resource provider, which acts like an interface for extra service in the future, to give us any proxy, and then it will mitigate this with Proxy Manager. We'll get to this logic in a second. We'll mitigate with Proxy Manager and just give it back whenever it's ready to the job manager. So this was kind of all 3 loops are really there. And whenever we have already the job, we would send this to worker in Node. So the main process spawns configurable number of workers that actually does requests and aggregations. So we would send, this was act as a gate and as aggregator. Try to avoid blocking callbacks because this needs to be fast. We started with the stream capability, so you would actually streaming parts of stuff from workers to the master process, and master process was sending this back to clients. But we started doing gzip, we started doing other stuff, so we had to aggregate it there. We did also, for legacy reason, bot detection on the side of service. This is purely because of legacy reason. Again, the GC exposed to just have a control over memory. Because of the way it's throttling from up to down, the exposing of GC and forcing the garbage collector to kick in a bit more often, it's not causing massive problem of performance, because the number of requests that the scraper on top is able to handle concurrently is already kind of limiting the work that goes down, so this is not creating a massive issue. And we structure this, so this could be one process, or this could be one server running the downloader, or this could be multiple servers running with HA proxy, for example, and sticky sessions. So what we implemented in the part of the process that was responsible for actually managing proxy, was a lock that would use mainly Redis for this. And this would allow us to spawn distributed processes on different architectures. And even if they would try to use the same proxies for some reason, they would be blocked. So it's like a multi-level step that we will be checking this if we can actually use the resource. On the beginning, because we were actually doing this for the PyScraper to work with it, and PyScraper on the beginning had still sessions implemented, which means you could follow with the same user agent in the same session the next request. We implemented JWT tokens that would give back actually the resource that you use for scraping, the proxy that you use for scraping, which means if the sticky session doesn't work, if the node is down, wherever it goes, if you pass the JWT token, you still have this resource. You can force the downloader to use this resource. The downloader will still check with Redis if it's not locked anywhere, and it would kind of be able to move it around. It of course creates some race conditions, but to some acceptable level. It was only the case when the sticky session is completely off and something doesn't work. And yeah, the downloader was the part that on our side was responsible for spoofing browsers, forwarding updates, for doing updates, for the compression, like whatever you wanted there. This is the part of the system that would be doing all this hard work. So as I said, something comes to downloader, goes to child process, got the content back, go to spider, this goes back again. So in this lock resource provider and proxy manager, it's kind of interesting structure that we. So as I said, the lock resource provider was only responsible in interval of time to see. It was keeping the number of requests that came in for proxy, and was actually getting for proxy manager, if it failed to get a proxy, was getting the release time of a proxy. So it was checking the number of items that were first in the queue. It was order hashed map. Would be checking all the top proxies until it moved past the current timestamp to see if proxy manager, if they were released, or something changed with them. And plus the situation when you would have the proxy that you used previously that you passed with JWT, and then using this one apart from whatever proxy manager got from the system that manages actually the proxies. So as I said, you will receive the proxies. You will receive the proxy to go to job manager, and then job manager would decide on the process that should, one of the workers that should actually do this. It will just be simple checking of how many jobs are unaccounted for in worker. So you have 3 processes, you have 2, 2, and 1. You will pick the one that has 1. You will just set it there. Nothing really complicated. Though on the worker, there will be extra settings like how many concurrent crawls it actually can handle. If we cache those, if we put on the internal queue those requests in worker, to basically every aspect of this downloader is configurable, so you can play with it on the very different on many different levels. We would use, as I said, because we did like forwards and stuff, so we would do connect with the socket, and then a normal request would allow us to have a bit more flexibility on what we're doing on the network layer. If it failed, we would request a new proxies X times. If it fails X times, then we will X times give it a new proxy. All of those things kind of were built in so that this element should be as reliable as possible on the network layer for the other parts of the system to don't worry about it. So what we learned, HTTP modules, if the content is invalid, there is something wrongly formatted, you won't get an actual response. You'll get HTTP error and so long. do another request. You can, of course, do the implementation in the net library, but that's the decision that the Node Foundation did to not give you the raw response if you use the HTTP module. So clearing interval loops for the tests, we use this hard way. Our Mocha stopped exiting tests because of the internal loops. You would have to have control over it when we wrote our test. Cascading timeouts in terms of we had to fine-tune the configs between all the three services to don't have like a random happening events that were hard to diagnose. We did part with C++ add-ons in the downloader. So if you can imagine, we're aggregating the payloads there, gzipping stuff, and then we have also this like 8,000 items proxy JSON array with proxies. And then we are moving from one stack to another, like cool down ready. This is not really not really optimized for Node in terms of memory. So we did have a play with C++ add-on. Terms of memory-wise, spot on. In terms of processing time, it goes up. We try to use the Chrome V8 like their variables to actually have the same kind of ability, just using the internal V8 items. We kind of failed there, though. This is kind of the part of the process that probably future teams should be looking at when they want to update stuff. And it was actually predictable if you think about it, that you have something that you code from V8 to standard string and then you copy back. It makes all sense that it took like more, but the memory was spot on. And as I said, the other thing was that we needed really to fine-tune the throttling from up to down. We couldn't just set random number and expect it to work properly. So we needed to have a proper number of workers for the proper number of jobs that we would set down. We would diagnose this by looking at our logs and what's happening and how the whole system performs. Yeah. What would I hope we could have done from the start? Because we kind of started this from the bottom up, we never really bothered with like tracing the single requests from when it enters the services till it ends, which means by whatever we are scraping, we would understand like this is the ID that we're scraping on this page, but it's in 50 gigabytes of log that we currently create there in Flabit. It's just hard to spot what you're actually doing. More metrics definitely, so we know how long the single curl through proxy takes to the domain. We know how much spider takes, but there are like a lot of small places where there were metrics like this would give us a benefit to understand where we can optimize. Separating concerts in downloader. This part of the rotation of the proxy that we did is like now that I think about it, it seems to me it's like a perfect example of things that you should separate to service, right? But we were doing this the first time. We are doing the service to work with another one, and this wasn't really like our goal. We just wanted this to be reliable tool to work with the previous service with as much as compatibility that we can have, because there was only one Python developer there working on this stuff. So to try to mitigate this pain and better integration with TMS proxy intelligence. This kind of goes together with the tracking of whatever's happening. So we actually did extra process that was kind of socket IO, spawned. We would actually start gathering stats, but we saved this to SQLite because the initial goal was 50,000 a day. And then we started doing 50,000 an hour, and SQLite logs stopped being at all acceptable solution. So we completely switched it off. We did kind of like, because you got from time to time bot detections, and this service isn't handling them. This service is just saying, we've been bot detected, sorry, error. Of course, it will retry and do other stuff, but if it fails as bot detection. So what we did, without having this process and without having be a bit crude about it, we did analyze our own log to search for those bot detection and then push these to the previous Python system in the format that they understand. I think, yeah, this part that is connected with the TMS is probably there. I don't even know why it's called TMS, to tell the truth, because it's system to manage proxies, and they call it tester management system, but this has nothing to do with TMS. This is just internal name that the company is actually using for it. But yeah, this is probably the stuff that they need to tackle on. Again, the R&D on C++ add-on, it was really promising what we did. We didn't have time to spend on it more. And as I said, the analytics for proxy usage, this is probably the direction the project should go at this point. So topologies, it's at this point it's like a Lego really. You can have it with HA proxy, or you can have this part in AWS, part on some VM. It really doesn't matter at this point. What matters is that you just do the configs properly, and you can set anything anywhere. You can have a pod in Amazon that has all 3 services, or you can have 3 pods, or you can have service in Amazon that does Go Spider that uses CPU more, and the other one puts on the box in your office. There is no limitations really to how you can do a topology at this point in the network. The most limiting part would be downloader, but downloader can handle distributed logs, so whatever goes really, and whatever can reach RMQ on the input, no limitations. This is example of a AWS topology that we did for Flabby. They're actually not using this now, but as you can see, you would be talking with other services by RMQ. This would come to the sets of scrapers, how many would set in deployment, then sets of spiders, then it would be connected to whichever downloader is connected with the input queue in scraper. Talk with Redis wherever Redis is, can be in AWS, can be something else. You can really play with this. And I was saying the scraper update as it uses the same Docker image as scraper, is just actually calling a different file from it. With the same config, everything else is the same. So this example stack for the AWS. Terraform, of course, on Rancher, Kubernetes with Docker, everything built and managed by the Jenkins pipelines. The first scraper using Mongo, Spider, downloader, Redis, and TMS. You can all spread this, and basically we started with one monolithic application in VM. So in terms of metrics, 2-core machine on they use currently Melbourne. I think they changed the name to something else. I don't know what the new name of Melbourne is. Maybe some of you know. So 2-core machine, prefetch of 40 on scraper, around 8 jobs a minute, which gives you around 700,000 a day. On the 8-core machine, where we're doing 2 times 60, this gives you almost 2 millions, and this is not the limit of this machine. You can still push more. This is just the number that the business wanted. They wanted 30 million during a week, and this is what we accommodated them with. Yeah, as I said, we started struggling with 50,000 a day, so that's kind of nice progression there. The cache that we are gathering, so the payloads that we scraped, roughly currently from this 30 million a week takes 7 gigabytes in Mongo. This is with around 2 or 3 million pages that are 404. So you need to calculate this, and every day sends around 12 gigabytes logs to Logly. So because we did it like this, and we kind of did it on purpose because we had already plans and we kind of did tests with other stuff, the scraper is now able to integrate it with bot. The scraper and the downloader is able now to integrate with bot network. So normally the TMS gives you the list of proxies. You can use those proxies as you see fit. But if you give one of the proxies as bot network, nobody says you know. And as the proxies has a cooldown from 2 to 5 minutes randomly, you can set this bot network proxy to be 10 microseconds, which means you can, in every cycle, you can still use your proxies, plus you use this one, and it still works fine. We did test with this, and this is really cool thing. They never got it out. The scraper would be actually talking with a system that has the Flabbit Chrome extension installed, and we did it over socket.io with the Chrome extension. And you can actually ask the Chrome extension to, first of all, to send whatever the user is seeing now, so whatever they're viewing, or do arbitrary other pages, which which is probably less legal, but it's doable. It's doable. We tested downloader with Tor. So you don't want to pay for proxies, you don't care about speed. Hey, Tor works. We tested also, the downloader has also extra kind of worker to send it to the Chrome driver process that we did. And this is part of the other stuff that I used to do in Flabit. We did like a auto ordering from Amazon, which means you would send me an ASIN and I would log in, check out, check basket, put an address in that you need, go to review page, do the print screen or review page, show the review page to the agent. Agent would say it's fine, and I would say I would just buy it. So and then we actually managed, like in test environment, to pull this into downloader. Then you would be feeding the proxies again from the manager, passing this to actual browser and browsing not with pseudo curl, but with actual browser there. And this box that is running currently, this 30 million a week, this is the usage. Everything is taken. And if you think about it, it makes sense. First of all, the scraper that he connects with Mongo, it does the 40 prefetch, but this is the optimal number of which it doesn't compete anything over CPU. The next one is well, you don't see this, but you have a spider. So if you do enough jobs, whatever the resources are left on the CPUs, the Go will just fetch it. It will just spawn as many Go routines as it can and allow it to work. So again, heavy stuff. And downloader of this stuff is probably the smallest if it goes for the CPU. It does only when it does actually decompress and send requests, but it's like almost all of this stuff is actually taken by putting stuff to Mongo and by analyzing content in Spider. So almost nothing for the request that you're doing. There were a lot of people that work on this. I have to thank them now. I mean, there's only one person, Ahmed, from the bottom of the list, that is currently here, but they all kind of put their effort in the whole project, and from the start of PHP version to the current proper microservice. And yeah, thank you guys. Cool story. If you're interested in this, I know they're hiring. That's the name of the new CTO in Flabit. You should contact him. You can say that you've seen very nice talk in LNAC.
Oh, well, thanks very much.
Thank you.